It's a pleasure to be here. I feel like I'm talking to a bunch of friends now, especially after this week and the last few days and the dinner last night. I think most of y'all know who the ARM is, but I do need to go over it for those who are online and who don't know completely who we are. So the ARM Institute is one of the 9 DoD institutes. We were set up, the urban legend has it that we were one of the last orders that President Obama signed on his last hours in office. I don't know if that's true, but I really like the story. We were set up by President Obama at the end of the office. We were also an institute because we're really revitalizing the U.S. economy by producing new industries that will create a lot of jobs and do create a lot of jobs. And so, we're really well funded by the current administration as well and the previous ones. We were established in 2017, which is quite a few years ago now, by CMU University, Carnegie Mellon in Pittsburgh. What's neat about Pittsburgh and relevant is within like a 3-mile walk, actually I think it's 2 miles from Carnegie Mellon's campus, there's like over 100 AI and robotics companies that you can actually walk to. So it's a very young city. It is the center of mass of robotics. And it's a great place for us to have been founded. We started off with $80 million from the DoD. We doubled it with Workshare and fundraising from the consortium. So that got us up to $260 million. And then with additional funds that we won in directed contracts, we had $300 million. So when people say, what do you do? I like to say, well, I've been invested with a tremendous amount of trust to be the steward of about a $300 million fund to reinvigorate the U.S. economy and to do it by reimagining manufacturing and investing in capabilities that allow you to use robots that are probably enhanced with artificial intelligence to do tasks to support the supply chain, fab, finish, assemble, disassemble, inspect, pick, pack, place, et cetera, everything you do in a factory and everything you would do in a distribution center. And we've been very successful at it. About 68% of what we invested in is actually transitioning into manufacturing, which is actually a pretty good record for what we do. And considering we're not doing layups, and what I mean by that is we're not doing projects we know are going to go. Of the startups, because we're part of what we do is the ecosystem of the startups we've founded, a significantly high percentage, I think it's like 2/3 of them, are successful, healthy, and growing. And part of that is through our ecosystem. You could be a startup and put on a team shortly later with a major manufacturer of automotives or a major defense contractor that you would have never met otherwise. We have a complete ecosystem. We're 345 members. Everything from J&J on one end of the spectrum to Boeing in the aerospace area, to Northrop Grumman, to FedEx in the logistics area, to startups. Minggu Kang just left. He was one of our startups, as small as well as mediums, including integrators. So it's a pretty good corporate broad-wise, and it's very good from FFRDCs, federally funded research and development centers that we work with, as well as a plug-in to Department of Commerce, which is one of our bigger funders, NIST, as well as Department of Education and Department of Labor. So again, and I'll cover it in the next slide where we are. So Vision of the ARM Institute, why we're set up, we like to think we're leading the way to a future where people and robots work together to respond to our nation's greatest challenges, to develop robots enhanced with artificial intelligence to make our factories the envy of the world. I changed the new template, so the last sentence I just spoke to you, it's actually behind the picture. But really who we are is the people. I don't have a technical staff. We're gonna have a few systems engineers. We have mostly program managers. Our technical staff is the technical staff of the consortium, which we leverage to do our jobs. So if you really look at our mission, so we have our vision is, again, this new world order where people work with robots to make the greatest goods in the world and the most envied of all nations. So how are we going to do that? So we accelerate the development and adoption of innovative robotic technologies that are the foundation of every advanced manufacturing activity today and in the future. I actually have to read that because that's official. And we leverage a unique, robust, and diverse ecosystem and partners to do it. But really get down to it, We do the top two things to get the bottom two things. So again, make robotics, autonomy, artificial intelligence more accessible for US manufacturers, large and small, as I described what our ecosystem looks like. And then there's no point in developing the technology if you don't have a workforce to use it. So train and empower the manufacturing workforce to use this technology. And by the way, it doesn't mean train people to put things together in a line. It means train vocational subject matter experts to teach robots, train mechatronics technicians to maintain these robotic factories, train mechatronics engineers to design the layouts, and then your traditional factory staff. And why do we do that? To strengthen our economy and global competitiveness, because if we're successful, that will happen. We're basically trying to run low-cost labor out of the equation, low-cost, low-value labor, so you can manufacture anywhere. And again, these new factories will be springing up like mushrooms all across this country near distribution centers. Because if we can get rid of that $20,000 cost of a container, we can get rid of all the fuel it takes to bring it here, and we take that distribution cost away, we can put it back into manufacturing. And that will bring the supply chain back. And then elevate our national security and resilience, because if you go back to World War II, one of the things that won the war was our ability to make Liberty ships. We could make ships faster than people could sink them. Not a pleasant thought, but from a military perspective, without an industrial base, you run out of weapons real fast. So who are we? This is just a little overview of our 345 members. A lot of folks in this room are members. So I kind of said, so we got Yasukawa. Where's Roger? Roger, if he's not here, still was here. We've got Fanuc. We've got Carnegie Mellon, Raytheon, which also is UTC. We have FedEx and Spirit. Spirit was briefing earlier. Of course, A3, we're at the A3 conference this week. Siemens, Universal, Lockheed, Yaskawa. I'm not going to go into it, but I could go on for probably 10 minutes naming companies. What's important about the companies is what we span. And like I say, our value proposition is we have really the power to convene and leverage the Institute. The Institute's broad. So we have the largest DoD and consumer OEMs really around, Fortune 50 to Fortune 500. And these aren't all of them, just examples. So if I leave someone out, please don't get angry at me. But Boeing, Lockheed, Raytheon, Northrop Grumman, General Motors, Stellantis, GE, and then we do a lot in textile. And I like to think of myself, my wife doesn't stop laughing. You guys have heard me tell the story, but I'm not a fashion guy. I hate shopping. So I find it odd when I speak at fashion conferences. So we have companies like VF, Vanity Fair, Hanes. We have the fashion industry in our consortium because we don't make garments for ourselves. Apparel and footwear, we're not really making that much of it in the United States. We still have good quality footwear. And so we're trying to reshore an industry that we should be the best at. We used to be the best at in the world. We make the best cotton in the world, or we grow it, and it's made into goods overseas. Dominant share of the autonomous mobile robot suppliers. We have 50 of them in the company. Industrial robot suppliers, over 50 of them. Again, logistics giants like FedEx. But by the way, Lockheed, Boeing, J&J are huge logistics companies as well. Smalls, mediums, and startups. I mentioned some of them earlier. 75 are robotics, autonomy, and AI integrators. And then top universities, I'm not going to offend someone, CMU, MIT, Georgia Tech, UCLA. I can't believe I don't have USC on here. SK Gupta, University of Washington also, and other great institutions. We do a lot of focus because remember I told you there's no point in developing technology if there's no one to use it. We're focused on vocational subject matter experts, and we're focused on mechatronics technicians. And those, you don't have to go to a big four-year college. So we have a huge group of VOTECs and community colleges, training centers, even down to including programs for people coming out of structured living, also known as the criminal justice system, depending on which state you're in, as well as veterans who are moving from posts or coming out of the military, as well as wives of, or spouses, I should say wives of, spouses of military personnel who transfer from base to base where there's huge shortages of robotics technicians. Would it be nice if you were certified to be a robotics technician in Washington and you moved to Florida and now you can get a nice job? In terms of the government, Army, Navy, Air Force, Marines, NIST, NIOSH, DOL, DOC, et cetera, and most of the big industry associations, big with the MVPs. So, where do we stand for the commercial folk? Not everybody gets this. There's this thing called TRL, Technology Readiness Levels. We're in 4 to 7. I'll translate. We take a prototype that someone developed in a lab, the proof of concept, the one you ginned up in the backyard, the one you hurry up and made. And we will invest in these companies to bring it to a prototype that's been demonstrated to work on a factory floor. That's 7. We're not going to do route cards. We're not going to do final, transition to manufacturing and lower initial production. Do that on your own nickel. In terms of IP, any IP you bring in, you keep. Any IP we fund you to develop, you keep. But the DoD does get government purpose rights because they paid for it. And in terms of anything that you bring in afterwards, you keep. So we're like a VC that doesn't take equity in your company or charge you interest. In fact, we pay you. So just to give you an idea of some of the things we do in terms of finished goods and robotic capabilities. So for robots that are used in supply chain, remember I said we start at the supply chain to support manufacturing. So, we had Picnic up here earlier talking. So we do pick, place, pack, unpack, stack, unstack, consolidate, stock and restock, and then transport things around and load things. So we do it to things to assist people so they don't have to reach the bottom shelf. Or if you're tall and trying to reach a bottom shelf, it can injure you. Or if you're short and trying to reach the top shelf, you can injure yourself. We do robots that support that, and we're driving towards near lights out distribution centers. In terms of robots that are traditionally used in factories, fab, finish, assemble, I'm not going to read through all of these, but forgings, castings, moldings, extrusions, every single manufacturing process you can imagine to make something, we invest in that. We've been developing robotic capabilities to do those things. And then if you guys got to see Aryan Kabir and Gray Matter while you were here this week, so that's sand, grind, polish, and camphor. That's a really good product. We're very proud of it, but it's scan, plan, do, inspect, and redo till it's done. I was totally pumped when I saw this morning, Kat was talking, and we're now going to have a Ross module, scan, plan, do. We've been invested in that. I think it's a holy grail when you really want to get to these really efficient factories. Be able to have the robot teach itself to do the job lowers the barrier of training someone now to operate that robot. Robots supporting warehouses and distribution centers, it's the same as the ones used in the supply chain. And then robots supporting maintenance and sustainment centers. People don't think of maintenance and sustainment as much. Maintenance and sustainment is what you do in every factory when something gets dinged or boogered. You have to take it out of the line and repair it and put it back in. You may not do it on a low value object, but if it's a car or a boat or something of high value, you'll go do that. We do a lot to the maintenance community. Space now has a sustainment business case to it. In Florida, they have to rework and re-maintain all the boosters that come back from space. So I don't want to go too much. I'm going to run out of time here. We focus around 5 things. Just look at this as our strategy of what we're doing and just keep it as strategy. So I don't like the word risk reduction for transition to the factory floor. Basically, we will fund the development of tools to take the risk out of using robots to do something. So these are tools that tell you if there's a good business case to use robots. So one is, make sure people are making prudent decisions when they decide to use robots. We will fund the development of that. So if you have a big tranche of money you're trying to invest to do what we want to do, these are the strategies and the things you'll invest in. Make the human-robot interaction more efficient, which means easier human-robot interfaces with less training that are safer. Interoperability, make them interoperable as your strategic command. Robot to robot, robots that work together. These are your fleet management things. These are the things that coordinate arm motions. And then reconfigurable, agile, and flexible robotics. So these are modular robots. So I could imagine anybody saw them in the video or the Ready robotics software. I could imagine I have a software with high resolution that allows me to very quickly model a factory. And I imagine I have a warehouse of bits and bobs of robots. I could very quickly imagine my factories go get the bits and bobs and set it up. That's a very agile and flexible factory. And then intelligent robotic systems, that pervades everything. And it's going to bring me back to Ross on the next slide. Those are what we do. So that's building artificial intelligence into robots. So now I got to Ross, why I'm here. So I'm one of the chief evangelists of Ross at the Arm Institute, to the DoD, to the government as to why it should be used. And one of the things before I get into this, I had the pleasure of sitting here this morning and watching. When you go late, you get to see all the presentations that come before you. I remember 4 or 5 years ago sitting here in one of this similar conference and looking at what we were trying to do with ROS. We were back at ROS 1.0. And I look at what we have now. I look at the maturity of ROS, but I look more at who was briefing here that's using ROS. We got Microsoft here. See more and more large companies adopting ROS. I saw MathWorks here this morning also. People were proliferating the use of ROS. ROS has become mainstream. 5 years ago, ROS was something that you used in college to kind of get you going. Now ROS is something you'd use to get product to that first level very, very quickly. I would tell you with a straight face, if you use ROS on an ARM product, on an ARM project, it probably takes a year off your schedule because every ROS module that you use does not have to be designed, developed, coded, inspected, debugged, verified and validated, and then put back up on the repository to use. I just go get it. All that work's already been done. All that money's already been paid for by somebody else. I'm starting with the module. My risk is reduced. Are there bugs in it? Yes. But if I developed it from scratch, would there be bugs in it? Yes. Do I need to do a code walkthrough? I might, but I'd have to do it if I developed it on my own anyway. So ROS is the best shortcut in the world to develop things quickly, to get them to be demonstrated and validated on a factory floor. And when you may only have a year to do that, it's a godsend. So just to give you an example, this isn't everything. We've funded now 100 projects. Again, some of them are EWD. They don't use ROS. But the EWD is education and workforce development. They're training programs. I would love to fund a training program using ROS or about how to use ROS. So we have now about 80 projects that have used ROS and about 80 projects that were technical. 65 of them used ROS. It's a huge percentage. And these are what we use. We use ROS IPA Coverage Planner. We use ROS Navigation and Move. We use ROS Swarm Control Stack. MoveIt is the most popular. GraspIt is one of the most popular. So ROS A5 software, heavily used. Snatch task level architecture for rapidly creating complex robot behavior. And then the other things are more in categories because, ROS no ether geo-constrained path planning. We do additive manufacturing. We do navigation across things. We actually maneuver robots in tough places. ROS discarded path planning, ROS GMAP, 2D SLAM, ROS 1, the DDS bridge, we all love and love. ROS I, MT Connect bridge, the middleware wrapper layer, and Gazebo. Gazebo is used on almost every project. How did we use ROS? Actually, I gave you a statistic before I was wrong on this one. 30 of 71 completed. Okay, these are completed now. We're performing programs have ROS modules, not just used ROS. These are ROS modules as part of their deliverables. So about half of what we've developed actually has a ROS module as a deliverable, and almost all of them use ROS. Most popular, MoveIt. Combinations. I was really disappointed when I started pulling these statistics. I wanted to show, we use this one this many times, this one this many times, and it ends up like MoveIt, Gazebo, all of the common modules. In terms of combinations, like for facility cleaning AMRs, it was ROS IPA path planning software and ROS Smatch. So just examples. Success stories. I'm not going to steal thunder. There's somebody here who's going to go, not the next presentation, but the presentation after me. It's Watson Technologies. We funded them. We're a interoperable middleware for robotics. And I'm really proud to say it's not about just taking and using ROS, and we've done our lion's share of that. I'd like to say we've been evangelizing ROS to the DoD, evangelizing ROS to these large companies so they're more comfortable using it. But now we actually got to give back to ROS, and I'm kind of proud of that because, with the DoD, we're not going to let secrets out. We're not going to let, things out, but we were able to get this one put back in. And it's going to improve things. And ROS is a way to deliver the technology we've developed for the benefit of the robotics industry as a whole. And this will be the first of many. So I'm not going to talk about it, but they're up today after me. And with that, I just want to summarize real quick. ROS shrinks time to market, period. You don't have to develop those modules. If you think of the number, just do slogs. If you just think of the number of hours it takes to code a line, you think of how many lines are in a ROS module, you're saving 6 months to a year by using ROS in your development timeline. And I would argue you might be saving more. Again, the other thing too, if you want to stay closed source, you can always develop the prototype or pathfinders using ROS. And then, if you want to be crazy, recode and do your final de-risk, or at least do a code walkthrough. Why recode what works? And then many of the projects we sponsor use ROS by choice. It's really a discriminator for reducing development risk and schedule. We ask people, why do you do it? It's always time. I couldn't finish the project on the time within the 1 year we give them if I didn't use ROS. The other thing was it's already there. The other thing was it was actually easy to use. But again, a lot of these guys are graduates who've been using it before. And with that, I only have a few minutes, and I have more because my flight's late, to just have any questions anybody wants to ask.
Questions for Arnie? Thanks.
Yeah.
Are your contracts similar, or is it?
No, they're totally different. We do not do SBIRs because. Oh, the question was, are the contracts typically SBIRs? No, we don't do SBIRs. We do full and open competitions, and they're out to all members. And you actually, to actually be part of a team, you don't have to be a member unless you win. Then you have to be a member and join. If you're a pre-revenue startup, it's almost practically free. And if you're a real large program, well, then you're contributing to the institute, so it's more expensive. I'd like to think we're a high value. I don't like to think any of our large members are here for charity. I think they get good value out of it. But you could say it's kind of like a SBIR. The only difference between us and a SBIR is we require a business case, a value proposition, a transition plan, an end use, someone who's going to actually use it, because we are graded on it transitioning to the factory floor. And I always tell people, it's pathetic to write the world's best book of poetry that nobody reads. And we don't want to be pathetic. So we really want what we've invested in to be used. That's our true impact. It's used and it's disruptive.
Thanks, Arnie. Thank you.